look at the manage DB, we should see under external stages schema that there are a few stages. So what happens with the stages when we are cloning them? Will they also be cloned or not? Let's have a look at this now. So first of all, we will execute it. Also, we will make it a transient schema as well. It will be called external stages copied, and it will land in our first DB. So let's execute it. And now we can quickly, after this has been done, refresh, and we can have a look at our first DB into the copied schema. And we can see this is the wrong table actually, so let's have a look. Stage copies it should be. So let me again refresh. And now it is appearing, and we can also see that the stages are also there. So this has worked. Also, the stages have been copied successfully. And now let's also have a look at what happens when we want to clone databases. So again, we will make this into a transient database. So this works. And if we do this, we will start from the entire our first DB. Then we want to have now an entire clone of this entire database. So this will just take maybe a couple of seconds. And then this has been finished. And now we want to, of course, have a look at the result. If this is actually here, so let's have a look. We can see our first DB copy is now also there. It has just been created now. And we should see all of those objects. So we can see the copied schema is there. Also with all of the tables, we should see the external stages copied also. So this is all available as well with our stages, and everything should be available in here as well. So this is how we can use the clone command also to use zero copy cloning on different objects like stages and databases. Of course, in our case, to clean things up again, let's drop those objects again so it is a bit more cleaned up and well structured here. So I will just drop the database. I will also drop the schema in our first DB, and then also this copied schema as well, so that everything is cleaned up again and we don't have any unnecessary objects in here. All right, so hope this was helpful in demonstrating how we can use. In this lecture, we now want to have a look at how we can use the cloning feature in combination with time travel, which can also just reduce and optimize the efficiency and the storage that is used. So therefore, we practically want to demonstrate how this works. And we want to, first of all, of course, set up our table. So we will set up just a table called time travel. We will also, just in case you haven't done this, execute this creation of this file format as well, and then load some data from this stage that we will create. So if I just set up all of those objects, I can see that now if I use the list command on this stage that I have just created, I will also just see this customer's data. And I can, we already know this, just copy this into our table that we have just created from this external stage. We see the data is there, we can now query it, and we should be able to now see something in this table. And now, of course, what we could do again, we could do some update. And now if I do this update, I can understand that potentially I have made a mistake and I have, not done this correctly. So maybe I can now travel back in time. And of course, now you maybe have to play around a little bit with the offset because, it can be a bit tricky. But if I run the select like this, I can see, okay, here in this case, first name was still correct. So if I don't do this, but I just create or query the table directly, I will see that here the change has already happened. But like this, if I do it like this, I see, here. So we have to, like I said, play around with it a bit. So I choose just now 1 minute. And here I will also choose 1 minute. I will quickly verify if this still works. It still works. And now let's go ahead and create this clone. I will just execute it. So the offset is still working. But what we have done here is that we have just created a clone from this time travel feature. So basically, this is a new table that we have created using the cloned command. So we just use zero copy cloning, and we use just our original time travel table with this offset. So we can not only use this in a select, but also in the clone command. So we just have the table and we add then here add, and then here this time travel capability. So here in this case add, and then offset, how we have also done it previously in the time travel feature. This is no different here, apart from, of course, we don't use a select, but just here this clone. And we can now quickly check if this has worked as we have expected, and indeed it has worked. So now we also want to demonstrate that we can actually also, of course, use here the different time travel features. So for example, we can use this feature also in combination with time travel from a statement, so we can travel before a statement. And additionally, we can also create a clone of an already cloned table. So a already cloned table is just as any other table, and therefore we don't have any difference. We can easily also clone that again to another table. So let's also demonstrate this. Let's assume again we are making some update that we don't want to do, some kind of an accident, and then we have here this query ID. So if I will just go ahead and actually copy this, so I just want to get actually the query ID. So I will just go ahead and copy it. And now I want to just paste this here. And it seems like we have also forgotten here to end this single quote. I will paste this query ID in here. Of course, we know we can use this with before and statement so that we can travel before the statement. And now in the same way, we can see this looks like it has worked. So here the job is still correct, while of course, if we have a look at this table without time travel, we can see here everything was still with the wrong update. And now this is the same thing as before. So as we have seen here, we just add this in the same way as with the select. And also in here now, with this before statement, in clone, it also works the same way. We just add before, then we specify our statement. In this case, we can also insert it in here. And then we can now create this basically clone of the clone, which is just, again, a normal table. And if I do this, I see that if I now query from it, this is our table as it has looked before. So we have now combined the cloning feature with the time travel feature, which can be very convenient because if we copy data, it makes sense to use this cloning feature. It is much more efficient. It is faster because no actual data is copied. It is just a metadata operation. And of course, also in regards to the storage that is used, it is also very efficient. So like this, it can make sense to combine the zero copy cloning with the time travel capable cloning, which is swapping tables. This can be especially useful if we, for example, want to take a development table into production or a development database into production. So of course, there would be multiple ways of achieving this as well. So for example, we could create a clone or a copy of our development table and then just rename this clone into the production table afterwards. However, Snowflake offers a much simpler method, which would be to just swap those two tables with just one single command. So like cloning, this process involves only swapping actually the metadata. So this is again just a metadata operation, and like this we can achieve this very easily with just one single command. So let's have a closer look at how this works. We want to understand that when a table is stored in Snowflake, it is of course not actually stored in Snowflake itself, but the data, the underlying data of the table is of course stored in an external cloud provider, and we just have the metadata that is associated with this table so that we can work on this table, do our queries and so on. And this swapping is also just a metadata operation. So when we swap those two tables, all we are actually doing is just swapping the metadata. And then the storage, the underlying storage of those tables, is just pointing to the metadata of the production table. So then this will be our production table with all of the associated metadata. And of course, vice versa. So we basically swap those two tables. Also, this just requires one simple command. So it is, of course, technically just one command. And also for us users, it is also just one single command to swap those two tables. So this can be very useful, especially when we want to have this use case of bringing a development table into production. To be able to do this, we can just use this simple command. We alter the table and then we use the keyword swap with. So like this, we are just swapping the table, the original table, with a given target table. And just like this, those two tables will be swapped. And we can do the same thing also for schemas. So here we can also just alter the schema and then swap it with another one. So this is also very simple in the same way. So therefore, let's just also quickly have a look at this in practice in Snowflake. Look at the swapping feature in practice.